Section 3.4, Trigonometric Identities. In this section, we will establish trigonometric identities. So before we talk about what that means and how to do it, if you look at the second bullet point, it says the ability to use algebra to manipulate trigonometric expressions is a key skill that one must have to establish identities. All right, so before we talk about establishing identities, we are going to look at some basic algebra that you're going to need to know that incorporates trig functions. So we're going to do some practice with that before we go on to the establishment of trig identities. Okay, so let's take a look at example 1. Example 1 says, simplify each trigonometric expression by following the indicated direction. So part A says rewrite in terms of sine and cosine functions the expression cotangent of theta times the secant of theta. All right, so if you see directions like this, okay, you've been given this trigonometric expression, okay, make sure you understand the difference between an expression and an equation. Okay, an expression does not have an equal sign. Okay, so no equal sign. Okay, an equation has an equal sign. Okay, so you've got to pay attention. You know, are you dealing with an expression or are you dealing with an equation? Okay, so what we've been given here is an expression. There is no equal sign. You just simply have cotangent of theta times the secant of theta. And what you need to do when it says rewrite in terms of sine and cosine functions, we're going to take this expression and we're going to manipulate it, okay? And we want to be left with an expression that has only sines or cosines. You no longer want to see a cotangent and you no longer want to see a secant, okay? So let's try, okay? All right, so we're going to start off with what we were given, okay? Cotangent of theta times the secant of theta, okay? We're going to start making some replacements, okay? So for example, what do you know about cotangent of theta? Okay, so I'm going to come out to the side over here. Okay, we know a couple of things about cotangent of theta. We know that the cotangent of theta is 1 over the tangent of theta. Okay, we can use that. Okay, so in the expression, we could replace cotangent of theta with 1 over the tangent of theta. However, what that's going to do, that's going to put a tangent in our expression. Okay, we want to have sines and cosines, not tangents. Okay, so the most direct way of getting there, okay, is to say that the cotangent of theta, remember, it's also defined as the cosine of theta over the sine of theta. Okay, that's going to convert that part of the expression to sines and cosines. Okay, so we're going to go ahead and do that. The cotangent of theta is the same thing as the cosine of theta over the sine of theta. Okay, now we're going to do a similar kind of thing for the secant portion. Okay, so we need to multiply this. This is cotangent of theta times, we need to multiply by the secant of theta. Okay, again, we need to make a replacement. Okay, how else can we write the secant of theta? Okay, well, this one's more straightforward. There's not as many options. We know the secant of theta is the same thing as 1 over the cosine of theta. Okay, so now we've converted our expression to an equivalent expression that has only sines and cosines. Okay, so what happens here, okay, you can go ahead and you're multiplying fractions here, so you can multiply across the top. So this is 1 times cosine of theta, that's going to be cosine of theta, over multiply across the bottom, that's going to be sine theta times cosine of theta. Okay, and then you realize, okay, I've got a cosine in the top and I've got a cosine in the bottom, and I can cancel those. Okay, so we're going to go ahead and this will cancel with this. So we're going to be left with 1 in the top and we're going to be left with sine in the bottom. Okay, so this whole expression has simplified to be 1 over the sine of theta. Okay, now you may be tempted to say, go one step further. I know that 1 over the sine of theta is the cosecant of theta. Okay, now be careful. Remember what the directions said. Okay, the directions, you want to be able to write this expression in terms of sine and cosine. So your answer needs to have sines and or cosines, okay? You don't want to see a cosecant in your answer. So you shouldn't do this, okay? So don't do that. You need to stop here. This is going to be the final answer, okay? Because it has, sines and or cosines, okay? So the cotangent of theta times the secant of theta is equivalent to 1 over the sine of theta.